So if you check the 10th questions, we are having 4 sub questions and we have to prove each matrix as the sum of a symmetric and a skew symmetric matrix. So we know for any matrix to be proven as the sum of a skew symmetric and a symmetric one, we have to use this formula half times A plus A dash, right? This is a symmetric matrix plus half times A minus A dash, right? This is a skew symmetric matrix. This is the formula we have to use in all these 4 questions, right? So the first question, for that we'll be finding the A dash first. So 3, 5, then 1 minus 1, right? Now we have to do A plus A dash, right? It would be 3, actually you can add it directly, right? 3 plus 3 would be 6 and 5 plus 1 would be 6, 1 plus 5 would be 6, minus 1 plus minus 1, that would be minus 2, right? Now we have to take half of this, right? Half of this would be half of this, so it would be 3, 3, 3 and 2 minus 2 by 2 would be minus 1, right? So actually you can check the symmetric, if this matrix is symmetric or not, we have to check, right? So just take the transpose and you would see it's actually symmetric. Now let's do the other part of the question, A minus A dash, right? A minus A dash, this is a symmetric matrix, we need a skew symmetric one now, right? So 3 minus 3, A minus A dash, it would be 0, 5 minus 1 would be 4, 1 minus 5 would be minus 4, and minus 1 minus minus 1, that is minus 1 plus 1 would be 0. Now we need half of this, take the half, it would be 0, 2, minus 2 and 0, right? Now you can prove this is a skew symmetric matrix. If you take the transpose of this matrix, it will be actually equal to the negative of this one, right? So this is a skew symmetric matrix and this is a symmetric one. Now we have to do this part of the question, right? So this and this we have to add it together. Now when you add these two, 3 plus 0 would be 3 and 2 plus 3 would be 5, 3 minus 2 would be 1 and minus 1 plus 0 would be minus 1. So finally we are arriving at this answer. So if you compare with the real matrix A, both the answers are equal. So thus we have proved A to be the sum of a symmetric and a skew symmetric matrix, right? So now we are having the second part of the question. So I have already found out the A dash, right? And this is our A, this is the A dash. Now we have to add A plus A dash, right? So 6 plus 6 would be 12, minus 2 plus minus 2 would be minus 4, 2 plus 2 would be 4, minus 2 plus minus 2 would be minus 4, 3 plus 3 would be 6, minus 1 plus minus 1 would be minus 2, 2 plus 2 would be 4, minus 1 plus minus 1 would be minus 2, and finally 3 plus 3 would be 6, right? Now we have to take half of this, right? Now for that we'll just divide every element by half, right? Now half divided by this means 6 minus 2, 2 minus 2, 2, 3, 3, minus 1 and minus 1. So this is the answer for half A plus A dash, which is actually the symmetric part of the matrix. But actually it's actually equal to A, right? Half A plus A dash, it's actually A because it's already a symmetric matrix. So when you do this part, we'll get A itself, right? So let's do the other part of the question, A minus A dash. So let's do first inside. 6 minus 6 would be 0, minus 2 would be 0, 2 minus 2 would be 0, minus 2 minus minus 2 would be 0, 3 minus 3 would be 0, and minus 1 minus minus 1 would be 0, and 2 minus 2 would be 0, minus 1 minus minus 1 would be 0, and finally 3 minus 3 would be 0. Now with this, it is a 0 matrix, multiply half, you'll get again the same matrix, right? So the skew symmetric part, it's actually a 0 matrix, whereas this is a matrix itself. So if you add both these matrices together, you'll get the same matrix, right? Because anything added with 0 would be the same, right? So this is the required answer for the second part of the question. So let's do the third part of the question. I have already found out the a dash for this question. So let's do a plus a dash. 3 plus 3 would be 6. Then 3 minus 2 would be 1. Minus 1 minus 4 would be minus 5. Minus 2 plus 3 would be 1. Minus 2 would be minus 4. And 1 minus 5 would be minus 4. Minus 4 minus 1 would be minus 5. Minus 5 plus 1 would be minus 4. And 2 plus 2 would be 4. Right? So now what we have to do, we have to take half of this, right? For the first part, half. So divide everything by 2. So it would be 3, right? 1 by 2. Here also 1 by 2. So minus 5 by 2. Then minus 4 by 2 is minus 2. Here also minus 2. Then minus 5 by 2. Minus 2 and 2. So actually you can check the symmetricity of this matrix. It will be symmetric even after taking the transpose, right? So now let's do the second part, half a minus a dash, right? Let's do what's inside the bracket first, then let's do the half of that, right? A minus a dash, this minus this, right? 3 minus 3 would be 0. 3 minus minus 2 would be 5, right? Minus 1 minus 4, that would be 1 minus 1 plus 4. So it would be 3. Minus 2 minus 3 would be minus 5. Minus 2 minus minus 2 would be 0. 1 minus minus 5 would be 6. Then minus 4 minus 1 would be minus 1 would be minus 3. Then minus 5 minus 1 minus 6. And finally 2 minus 2, 0. Now divide everything by half. You will get it as 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3 and 0. Now what we have to do, this is skew symmetric and this is symmetric. You have to check the skew symmetricity of this matrix also. Then finally we can add both the matrices together. 3 plus 0 would be 3. Half plus 5 by 2, it would be 6 by 2. 1 plus 5 would be 6, right? So 6 by 2, so it is actually 3 itself. Minus 5 by 2 plus 3 by 2, that is minus 5 plus 3 would be minus 2. Minus 2 by 2 would be minus 1. 1 by 2 minus 5 by 2. 1 minus 5 minus 4. Minus 4 by 2 minus 2. Minus 2 0 minus 2. Minus 2 3 plus 3, right? So 1. Minus 5 by 2 minus 3 by 2 would be minus 4. And minus 2 minus 3 would be minus 5. And 2 plus 0 would be 2. So now you have to check with the real matrix. Both are equal, right? So if both are same, what you have done, it's correct. Otherwise some mistake you have made. So here actually we are arriving at the correct answer. So we have done it correctly. Let's do the fourth part of the question. So here is our A matrix and A dash, I have written it down. So let's add A plus A dash first. 1 plus 1 would be 2, right? Then 5 minus 1 would be 4. And minus 1 plus 5 would be also 4. And 2 plus 2 would be 4. Now we have to find out half of this, right? So it's actually 1, 2, 2, 2. So you can check the symmetricity of this matrix. It will be symmetric even after taking the transpose, right? So now let's do the second part. Half A minus A dash. So 1 minus 1 would be 0. Let's do the bracket inside first. 5 minus 1 would be 5 plus 1, so 6. Then minus 1 minus 5 would be minus 6, and 2 minus 2 would be 0, right? Now let's take half of this, so it would be 0, 3, minus 3, and 0. Now what we have to do, this is symmetric, this is skew symmetric, you have to prove it's skew symmetric too. Now finally we have to take the sum of both these matrices to find it's equal to the A matrix itself, right? So 1 plus 0 would be 1, 2 plus 3 would be 5, 2 minus 3 would be minus 1, and 2 plus 0 would be 2. So if you check, this is actually equal to the A matrix. So thus we have proved A to be the sum of a skew symmetric and a symmetric matrix, right?